use this to monitor the atmosphere over a particular area and see what conditions are happening there. So if you followed this, you would have been able to tell how pressures were dropping with time, and then using your NWP models, you could also predict what was to come for those areas. And then this is also verification using the aeronautical messages. This is the message from the Kotoka International Airport from um, yesterday, 10 p.m. till 9 a.m. today. So from 10 p.m. till around 7 a.m., even up to about 8 a.m. today, there was basically nothing happening in the atmosphere. Mostly high clouds, visibility very good, no low clouds there, no weather happening within that area. So we're getting some quite fair weather conditions throughout the night till this morning. But in the morning around 9, we started getting some few clouds, few low clouds at 2,100 feet. Temperature started rising, leading to some convection in the atmosphere. So at least this will also give you an indication of what cloud type of cloud is even happening in a particular area. And so you can use them to also predict. If you are seeing the kind of clouds there now, you can now use them to tell how they will develop based on the NWB models, and then make predictions for the future. All right. So yesterday I said that we'll go through how to use the same global models, but then try and use some knowledge of the local conditions to sort of adjust the model in a bit. So this is a form of model validation, but not so I don't know, you're not using so much calculations or anything like that. Just a personal one you're doing in the morning when you're coming to do your forecast. So we all use this site for forecasting. I'm sure you are very conversant with this site. So you know the cycles that we have here. So midnight cycle, that is when the model was run. So it means if you use that cycle, the charts will be starting from 0600. So it will be valid 6 hours after the runtime. If you use 06 cycle, the charts will start from 12. If you use 12, it will start from 18. If you use 18, it will start from midnight. So you know the cycle that you want to look out for, and then the time of the day, what cycle you should even go for. But I would not advise that you stick to one cycle. Let's say your forecast always starts at 9 a.m. Maybe you start writing a forecast at 9 a.m. And so, but by that time, the midnight cycle would have taken effect. And so every time you'll be using the midnight cycle because your forecast starts at 9 a.m. You want the current one to use all the time. I would not advise that you do that. The reason is that sometimes it takes a lot of time for these models to actually, um, I don't know how to put it, if acclimatize itself with the conditions there or whatever. I'm not too sure how I should call this, but it takes a while to be able to get the conditions correctly for the area. And so the advice I would give is that once you've gone through the satellites and then the observations that we've seen, and then you know what is happening at that particular point in time, use any of the cycles that were able to predict those conditions that you are seeing now as a form of validation for your model. So if I use midnight cycle, I came in the morning at 9 a.m. I want to make a forecast. I check the midnight cycles and I'm seeing very dry conditions for 09. But I'm seeing very moist conditions now. So the models were not really predicting those kind of conditions well. In that case, I wouldn't rely on that midnight cycle. I can go back to 1800 cycle and see if it also predicted the conditions I'm seeing at the moment. If it did, then it means I can rely on that particular model or cycle for subsequent hours to come. So the best thing to do is to use the observation, whether satellite or um, ground observation that you have received from the sites we've gone through to validate the cycle you should even be using. For us at the Operational Med Center, we have the luxury of getting different kinds of um, forecast models. So we don't only use this one. We have the ECMWF, we have the charts from UK, Met Office from Meteo France, a whole lot of them on our synergy. And so what we do is that at every point in time, we go through each model to see which of these forecast centers are able to predict the current conditions better. So if I come today and I see that ECMWF is giving me indications that there will be clouds this morning, and I'm actually seeing the clouds, but if I go to the other models, I'm not seeing them there. I'll rely on the ECMWF for my forecast. If I see Meteo France predicting the current conditions better than the other models, I will rely on the Meteo France for my forecast. So we are using the current conditions of the atmosphere to validate the models, which will then now be used for forecasting. Because if you're not able to predict what I'm getting now, what is the guarantee that it will be able to predict the conditions that are yet to come? It is not always the case though, but at least using this has also, in a way, helped improve forecasting here at Ghana Meteorological Agency for some time now. So we try to use current conditions, the ones that we've gone through, to validate the model and then now see which kind of model we should use. But because you may not have access to all these other models or forecast centers, if you're using just the INSEP model forecast for West Africa, these GFS products, then you would want to go through the cycles to see which one of them is actually predicting the conditions you are seeing now better. And then you can use that to make the projections for the future. I hope this is clear. Or if anyone has any question on this one. All right. So let's go on then. Okay, so we can get a whole lot of products from here, from 925, 850, 700, 500 to 200 hectopascal. But I would advise that you use the RH instead of the wind. If you want to use the wind, you probably this is a vector charter, so you don't want to use it if you want to know the speed of the wind and the direction of the wind. You can use that one. But because we want to know how deep the moisture is in the atmosphere, I would advise that you use the RH more often, because this one adds the wind and then the relative humidity at those pressure levels. And so it's good to use that one um, from the surface to the top of the atmosphere to see how deep relative humidity is from the surface going. If you're getting very high relative humidity at 925, don't be too comfortable with that. The fact that you're getting high RH at the surface does not necessarily mean that you're going to get deep convection happening. So you should be looking at getting that kind of moisture also reflecting at 850, telling you there's deep convection and deep moisture. If you see it on 700, then it means the moisture depth is quite high. And so if there's low pressure within that area, there are other favorable conditions there, and you can have very deep clouds building and then leading to some precipitation or rainfall or precipitation here within that particular area. So it's good to use the RH in order to see these kind of the kind of depth of the moisture within the atmosphere. And then you can also use the dew point here, temperature here, to locate your ITB. So this is at 2 meters, so it's quite closer to the surface. 925 hectopascal is around 700 to 900 meters, so it's not too close to the surface like the 2 meters. So if you use the 2 meters, it means that's close to the surface, and so it will give you better representation of what is happening on the surface than the 925 hectopascal will do. And like I was saying yesterday, this mean sea level pressure will just give you for West Africa. And so you would see the Azores area, the North African area, and then the country, Ghana. But you will not be able to locate what is happening over the ocean. St. Helena will not appear here. And so that will limit you. If there's a lot of moisture supply from St. Helena, you wouldn't be able to tell because you're not seeing that one. So as you look at this one, you also add the pressure chart from the ECMWF, which is also free. and online. You can always access them to get a wider view, the whole of the continent, and see which pressure centers are actually dominating within the day. I think yeah, basically that's all for here. Keep let's keep also here, and then convertive integration as well. So you can use all these indices as well if you want to make any forecast from here. All right. So I've talked about how you can use these same global models, but then use your data collected from the field or from your satellite interpretation to validate that model or the cycle which you should even use for your forecasting. So it's the same global models, but at least it's guiding you on which one you should use for your forecast. But away from that, you would make very good use of point information. And this basically go into telegrams. Um, yeah, like I said, this will be treated on its own, so I wouldn't go so much into this. If you're using these information, then you are basically getting an information for a particular area, and so forecasting for that area becomes easier rather than relying on synoptic scale information to forecast for a particular place. In that instance, there's a risk that your forecast will there's a higher probability that your forecast will go up because the conditions there would not necessarily reflect what the synoptic scale is giving you. So it's good to have point information and using point information for forecasting increases the probability of you getting your forecast right. So tetragram convergence and divergence fields will also try and give you areas where there's deep convergence or there's divergence happening, and this will also be at some specific areas. And so it will also help you when you're making forecasts for particular areas within the country. Same for the convective available potential energy, even though it's taking the whole country into perspective, but the energies will be different across. You would have maybe higher energies around some specific area. So you'd be so concerned about those areas and look for conditions at maybe on the wind chart or on your pressure chart to see if they are good for cloud formation or eventual precipitation within that particular area. So as you are looking at the global ones, try and use some of these information, the stability indices like I showed earlier, will all help you know conditions for specific areas and then tell you what you should expect within those areas. That will help improve the forecast, especially for you who will be probably making forecasts for just KNUST or Kumasi. You would want to know conditions around that particular area to make a forecast for them. But if you're making a forecast for the whole of the Ashanti region, then if you want to rely on the synoptic scale so much, you wouldn't have so much problem with that. But I wanted to give you a link that will give you some satellite telegrams for specific areas. Unfortunately, I forgot to put it here, but it is. I'll probably share it with you later. But you can just type air resource laboratory, air resource laboratory, and Google or any search engine, and then you would have current, ready current. You just select that one. It will give you a place to enter the coordinates for that particular area. So you can just enter your coordinates there, and then you just get a telegram for that particular spot. Because we don't do all sound in here, you wouldn't get satellite telegrams for specific areas here. And so you want to rely on some of these things. And it's from U.S. government, and they have been quite helpful over time. And so if you want to use them for forecasting for Kumasi or any place in the country, that would be quite useful. I'll share the link with you later, but I forgot to put it here. I think that will be all for today. Hoping that will close early. All right. Thank you. I'll just be on standby for any questions. Okay. Okay, okay. As in the ground observation or the satellite. Okay, okay. All right. So I was saying that we have stations across the country that report weather conditions for those areas to us every 3 hours. So that's the synop message that we get from there. You you would need to understand the code to be able to interpret it. It's not too difficult to interpret. I'm not sure if we are conversant with that. I can just take some few minutes to highlight some of the important messages there, if it's okay. Okay. Oh, okay. 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 That's not a problem. Okay. So let me start with the send up message. Let me- Okay. So basically, these ones are just telling you the time and then the date where the message when the message was sent. So this is 2022 October 25th at 0600, so 6 a.m. And this is just telling you that this is a message coming from a land station. So all the time you see this there. This is the date 25th, the time 06. This is 4. The 4 is always there telling you that the wind speed was measured with an instrument. There are wind speeds that you estimate. So someone will just go there, use their watch or something to time um, how long it takes the wind to move, the wind really to move from one point to another, and all of those things. So those are estimations, and so it would have some errors associated with them. Or if you use an instrument to measure it, in that case, it's more accurate. So if you see 3 here, it means the wind speed was estimated. But once you're seeing 4, it means there was an instrument that was used to measure the wind speed. So you don't really have to worry so much about these ones. They are not necessarily part of the message. And then this one is just the code, but it has been broken down for you here. So 442 is the code for Kumasi. 65 is the code for the whole of West Africa. So all our messages will start with 65, but these ones will differ from one area to another. So Accra, for instance, is 472. If you search the is around 445. 460 is Akuse. So there are a whole lot of them. But if you go to Ojimet, they will just state the station there, so you don't have to know how to like have the codes for all the stations across the country. So you don't really need that. The actual message starts from here, but you can also use this one to tell the visibility, this last two figures. So the 6.2 is telling you the visibility of the area. If it's anything less than 50 or below, just take the value as it is. So if you see 50 there, just take it, add two zeros, and then the value is in meters. So if you see 50, if you add two zeros, that's 5,000 meters. That's the visibility. If you see 20, just add two zeros, 2,000 meters. If you see 10, you add two zeros, 1,000 meters. If you're seeing 08, you add two zeros, that means 800 meters. But if it's more than 50, you subtract 50 from that value, and the value you get in kilometers is the visibility. So this one, for instance, is 6.2. So if you take 50 out of 6.2, you are left with 12. So it means the visibility is 12 kilometers. So that's what you should know for that code. This one is also telling you the total cloud cover. So the first um, number, 7, is telling us that 7 out of 8 of the atmosphere is covered by clouds. So we try to divide the atmosphere into 8 equal parts to record that octets. If you see 1 there, it means just 1 out of 8 of the atmosphere is covered. If you're seeing 2 there, so just telling you the amount out of 8 that is covered by clouds. So 7 octets means it's quite cloudy for that area. The next two figures, 2, 3, is telling you the direction of the wind. And then the last two will tell you the speed of the wind. So 230 means you just add 0 to that value, you get 230. So 230 means it's a southwesterly wind. We can just draw the cardinal points. Northerly winds will be 360 and 0. Easterly will be 90. southerly winds will be 180, and then westerly winds will be 270. You can have southwesterlies as 230, 160 as southeasterlies, 050 as northeasterlies, and then 320 as northwesterlies. All these values just plus or minus 20. So it's a range. If you pick the easterly wind, for instance, which is the direct easterly is 90, but anything within plus or minus 20 is still an easterly wind. So if you take 20 out of 90, you have 70. To add 20 to 90, you get 110. So from 70 to 110 is still an easterly wind, but 090 is a direct easterly wind. So 230 will take us to the southwest. So you use that one to tell the direction of the wind. And the last two, which is the 02, will tell you the speed of the wind in knots. So 02 knots. If you want to convert this to meter per second, you just divide by 2. So that's 1 meter per second. Yeah. And then these ones are indicators. So the main message will actually start from here. You have 1, 2, 4, 5, 6, 7, 8, and then 9. These are all indicators telling you what kind of weather you should be expecting over those areas. One is an indicator for the air temperature at the time. Two is an indicator for the dew point temperature. So this one, for instance, we have 10250. The zero here is telling us the sign of the temperature. If it is positive, you have 0. If it is 1, it is negative. So if we have 10250, it means the temperature is 25.0, positive figure. If it was 11250, then it means temperature is negative 25.0. And then the 2 is an indicator for dew point temperature. The same interpretation, a positive figure. The value is 23.2. And then this one, the fourth group, is an indicator for pressure. That's why I was telling you that pressure is dropping for Kumasi. So an indicator for pressure. You just put 1 before the 0, and then the last digit will be a decimal. So 1011.4. If you come to this one, it will be 1010.9. This one will be 1007.5. This will be 1011.2. So just put 1 before the figure and then make the last one a decimal. Okay. Okay. So if it's something like say 995 or something, right? Okay. So give me a minute. Most of the time, because these ones are 4 figures, that's why they take the 1 away. So if you are seeing the figures there without the 0, and then you have, let's say, 4, 9, 9, 5, 4. You will not have 1995.4. That will not be the pressure. So the pressure will just be the 995.4 without the 1. I don't know if it makes sense. Yeah. Okay. Yeah. Yeah. So you just pick it as it is. But for the ones you're seeing 00 there, you just bring 1 before, and then you add the others. And then there's a fifth group, but that will come later. But there's a sixth group and then a seventh group. The sixth group is actually used to tell the rainfall amount, and then the seventh group will tell you the kind of weather happening within the particular area you are considering. So for sixth group, for Kumasi at 1800, we have 60042. So this is telling us the rainfall amount rounded to a decimal figure, to a whole number, sorry. So you don't have decimals here. Even though the actual amount may come with a decimal, this one we round it to the nearest whole number. So you just pick the mid 3 figures here, and that will be your rainfall amount. So 004 means there was 4 millimeters of rainfall. We had 06112, it means the rainfall was 112 millimeters. The last figure here is telling you the accumulation of rainfall, the period that the rainfall has been accumulated for. So if you have 1 there, it means the rainfall is an accumulation for just 6 hours. If you have 2, it's an accumulation for 12 hours. If you have 3, it is an 18-hour accumulation. And then if you have 4, it's a 24-hour accumulation. So just multiply the last figure by 6, and we'll tell you the period it took to record that kind of rainfall. So this was a rainfall for 12 hours. So it means this was 1800. So it means we go back 12 hours. So areas time within that range gave us that kind of rainfall. And then there's the seventh group telling us the present weather. So there are codes for present weather and then past weather. 17 is a code for thunder without rain, present weather. 9-6 is a code for thunder and rain as past weather. Usually 9 will be for thunder, 6 will be for rainfall. So if you're getting 6 something here, it means there's rain happening at the place. But 9, 5, 9, 6, those are all rainfall codes. So they are all telling you the present weather and then the past weather. So this is telling us that at that particular time, at 1800, it wasn't raining. There was thunder, all right, but there was no rainfall. But in the past, it was raining with thunder. So the rain had ceased around that time, but there was still some thunder being heard at the Kumasi airport. And then we go to the age group telling us the cloud that we have. So 8 is an indicator for cloud. The 5 is telling us the amount of the lowest cloud. So it could be low clouds, it could be medium clouds, but if it is a high cloud, you don't bring it there. So if you have, say, 5, so this 5 means that the lowest cloud amount is 5 octets. So it could be low clouds, it could be medium clouds, but we can also use that then the subsequent code to tell whether it's a medium cloud or a high cloud. So this is just telling you the amount of the lowest cloud in the atmosphere. And then the next 5 is telling you the type of the low cloud. The next one is telling the type of the medium cloud, and then the last one is telling you the type of the high cloud. We have the slash forward slash here to mean that there's low cloud, there's medium cloud, and so we are not able to see the high cloud. This is 5 octaves of low clouds. There's also medium clouds, and these two combine to produce 7 octaves of cloud in the atmosphere. What it means is that just 1 out of 8 of the atmosphere is left blank. So it is highly impossible for you to see above that kind of cloudy weather. So if there's a high cloud there, it's very impossible for you to see that standing on the surface of the earth, unless you are probably observing from space, then you'll be able to tell. So you put the slash there telling you that there's high cloud, there could be high cloud, but you are not able to detect it. That is why you have that kind of code there. And then 333 is just telling you are moving from one sect of the code to another sect of the code. So you can have 10 here too. So 10 here means maximum temperature. 20 means the minimum temperature. Maximum temperature is reported at 1800. So if we go to 1800, we will see 10331, telling us that the temperature, the highest temperature for the day was 33.1 for Kumasi. And then minimum temperature is recorded at 06. So at 0600 UTC every day, you will see 20, telling you the temperature, the lowest temperature for that day was 24.4. Yeah. And then this one will tell you the pressure difference. So 59011 is just comparing the pressure for the past 24 hours. So this is at 06. So if you pick 06 the previous day and then the pressure at that particular time, the difference between them is 011. But 9 here is telling you it is negative. If you see 8, it means it is positive. So what it means is that if we compare the last 24 hours to what was reported at 600 yesterday, the pressure was actually dropping for Kumasi. But for this one, if you compare the 1800 to the 1800, pressure was actually increasing rather. So we are getting an increase of 010 if you compare it to the previous 24 hours. So this is just telling the pressure difference for 24 hours. And then now we are telling the type of the cloud, the amount of that cloud, and then the height of the cloud. So this was just giving us that an indication that there's low cloud, there's medium cloud, there's high cloud, and then the amount of the low cloud is 5 octaves. But this is going to tell us the type of the cloud and even the height of the cloud. So the first one is just an indicator that you are going to clouds. This is telling you the amount of that cloud, which is 5 octaves. This is telling you the type of the cloud. 6 is the code for stratocumulus. So just know that it's a low cloud. That is the most important thing. Once you have seen 5 here, it means there was a low cloud. So this is telling you the low cloud there. And then the height is 0.8. So just add two zeros to it. So 0.800, and you add feet. The unit is feet. So 0.800 feet. So 800 feet. If you're seeing 1 0 there, you add two zeros. You get 1,000 feet. You see 2 0, just add two zeros to it. So 2,000 feet with 3,000 feet, just like that, telling the height of that cloud. And then the next one is also 7 octaves of the medium cloud, because there was medium cloud here. And this is, I think, autocumulus. Yeah. No, no. This is not autocumulus. Autocumulus is 5. But I've forgotten the kind of cloud. But it's one of the medium clouds. Could be any of them. And then the height is 6,000 feet. So just telling you the cloud amount, the type, whether it's high, low cloud, and then the height of that particular cloud. I don't know if it's okay. And then the okay, it's just telling us that the message has ended. So you end the message with equal to. Yeah. And okay. Then we, I think it's basically, yeah, I think that's going to be. It will take some time for someone to really understand everything. But at least if you know the temperature, air temperature, dew point temperature, and then the pressure, I think that one is easy to understand. You'll be able to know some of the weather elements there, the values there, and then how they are changing with time. I think that's the most important thing. And whether there's any weather happening there, or the amount of rainfall that even fell within a certain period, within that time. That's the most important thing. The others, you don't really need them that much. All right. So we'll try and also do a bit of the meter information, so that you can also, yeah. Okay. So this is also telling us that this is a report from the Met Office at the Kotoka International Airport. The DG is D is the block for West Africa, G is the code for Ghana, and then AA is the code for Accra. Kumasi is SI, Tamale is LW, and then Takade is TK, WA is LWS. So there are a whole lot of codes for all the airport stations in the country. Accra is AA. So this is just telling you that there's a message coming from Kotoka International Airport. And then the date was written, 26th of that month. In this instance, you're not interested in the month and then the year. Just write the day of the month. So it's 26th, that's all. And then 0900 is the time that the report was made. So 9 a.m. So this is UTC. Zulu is the same as UTC. So 0900 Zulu is 0900 UTC or 9 a.m. 0500 Zulu means 0500 UTC or 5 a.m. Then this is telling you the wind direction and then the wind speed. So you're seeing the first three will be for the direction. 040 is the direction. So that is a southeast, northeasterly wind. So like I said, northeast will be 050. So if you take 20 out of that, it means 40 will still fall within that area. So 040 is a northeasterly wind. And then the last two will be the wind speed. So 03 knots. So direction, the first three, the last two is the wind speed in knots. Then we have this telling us that the wind is actually varying, but it is changing more than 60 degrees or more. If it does not change to 60 degrees or more, it does not qualify for this one. So this is the prevailing wind speed, the wind direction, northeasterlies, but it is ranging between 330 and then 140. 140 is a southeasterly wind. 330 is a northwesterly wind. So it means the wind is ranging between northwest and southeast, but predominantly you'll see more of the northeasterly winds. So this is the prevailing wind, but then they vary between this 330 and then 140. And then this is a code for visibility. 9999 means visibility is 10 kilometers or more. So if visibility is 5,000, we'll just write 5,000 there. If it is 7,000, we'll just write 7,000. If it is 500, we'll write 0, 5, 00, because the code is supposed to be 4 figures. So at every point in time, you have 4 figures there. If the visibility is three values, you'd have to start it with 0 so that your three values will now follow, and then it will make up for the 4 figures. So once you're getting anything 10 kilometers or more, it becomes 9999. So that's the code for visibility of 10 kilometers or higher. Then from there, we go to the clouds. But this time around, we are not using the numbers like the synop, 1, 2, 3 octets kind, but use the same interpretation to classify the few, scattered, broken, and then overcast. So we can have few, like it is written there. We can have broken, BKN. We can have scattered, SCT. We can have overcast, OVC. Those are all indicators of the amount of cloud in the atmosphere. Few means there's just 1 to 2 octets of the atmosphere covered by clouds. If you have scattered, SCT, it means there's 3 to 4 octets of the atmosphere covered by clouds. If you have 5 to 7 octets covered by clouds, that is broken, BKM. And then once the whole atmosphere is covered, it becomes overcast, so OVC, 8 octets cloud. All right, so this is just the amount, the few, the scattered, the broken, the overcast will tell you the amount. And then the 0 to 1 will tell you the height in feet. So this one, you just add 2 zeros, so 2100 feet. If you have, let's say, 010, it means it's 1000 feet. So that's just the amount of the height of the cloud that you are reporting. But in aviation, they are not so much interested in the type of the cloud, except it is a CB cloud, because CB clouds will have direct effects on flight operations. It can have some disruptions to flight control. And so if there's a CB, you'd have to alert the pilots that there's a CB cloud so that they will avoid that particular area and not go into the CB. It's quite thicker, and then due to the ability to produce thunder and then lightning, it can have some effects on flight operations. So they want to avoid it as much as they can. So you tell them there's a CB. So if this was a CB cloud, they would have added CB here to tell you that that cloud that we are reporting is a CB cloud. But if it's not a CB cloud or a towering cumulus cloud, you are not interested. So you don't bring it there. Just tell us the amount of the cloud and then the height of the cloud, and we are done. And then the numbers you're seeing here are temperature. So air temperature and then dew point. The air temperature is 27. This is just separating it from the dew point, and the dew point is 23. That's all. And this is telling you the pressure, the QNH at the station. So 1012. This time around, you're not adding anything. And there's no decimal in aviation. We run the pressure value down. So if you record your pressure and you get 102.9, don't run it to the nearest whole number. Just take the 9 away and report 1012. If it is 1012.1, we are still interested in the 1012. Don't run it to the nearest whole number. Just run it down. So we just pick that particular value there and then you put it here. So this is also called the altimeter setting. So if a pilot should enter this in the altimeter in the aircraft, once he lands on the surface, the altimeter will read 0, telling you the pressure in the altimeter has just been reached. So you're on the ground. All right. So this is very significant in aviation, because if you give wrong figures to the pilot, you would end up causing a crash. It's just like you descending from a stair and then you miss the last step, the way you feel when you land. That's kind of the same thing that will happen to the aircraft if they get a wrong figure. And then this no sig you're seeing here is a trend that we are adding to the message. So from here, this place to this point, they are all actual weather happening at the aerodrome. So this is not a forecast. This is the actual thing. But anything you see after the pressure is a forecast. So we call it the trend forecast. You are giving a forecast of what will happen in the next 4 hours. So no sig means there's no significant change in the weather that has been reported. So all the things that we've said here, none of them will be changing significantly in the next 4 hours. So it means we are good. But if we're expecting any significant change, maybe visibility will be changing from this 10 kilometers or more to 5,000 meters, then you have to bring a trend, maybe tempo 5,000. Maybe if the cloud will also change, you indicate it. So that will be a forecast. A forecast that's attached to the actual message at the airport telling the pilots that this is what is happening, but we expect these conditions to come within the next 4 hours. So it's only a forecast, a trend forecast attached to the message at the airport. I don't know if it makes it. Let me try and then break the KWalk 2 down. So KWalk actually caters for the with visibility, the weather, and then the cloud. Those three in one. So the term in itself means the cloud ceiling and visibility. Okay, ceiling and visibility. Okay, that's the KWalk or Kawoke or whatever some people call it. Anyway, so it means there's no low cloud in the atmosphere at the time. No CB, no cumulus cloud, no stratocumulus cloud, anything like that. There's no cloud below 5,000 feet. None of the clouds you are seeing in the atmosphere at the time is below 5,000 feet. So they are all either medium clouds or high clouds in the atmosphere. And then visibility is 10 kilometers or more. So you are combining three things: the visibility, the weather, and the cloud. There's also no weather happening in the atmosphere. There's no rain. There's no mist, fog, or anything like that happening. So all the three will come together. So once you see K-Walk or Kawoke, it means that the weather is good, visibility is okay, no cloud at the lower levels. So pilots will be happy seeing this kind of code when you send them the meter. That's basically a short interpretation of the meter code at the airport. But there's more to learn when you start doing aviation methodology. You'll get more on that. Okay. Yeah. Yeah. Okay. Okay. So it's a mixture of the two. For us at Kotoka International Airport, we use both the sensor and then manual observation. So we have sensors in the automatic weather station telling you the visibility. So automatically, it will just give you the visibility in the hours. But the disadvantage with that is that the sensor is placed at a certain point, and so it is able to tell the visibility at that particular area. It is not able to give you the visibility across the horizon of the aerodrome. And so most of the time, we use manual observation to correct that visibility. During the dry season, for instance, if you rely on that most of the time, you would have lots of problem with pilots. And so it's a mixture of the two. But this is how we do the manual observation. So that's the station at the airport or anywhere where we have the recording station. You have a point, which is your reference point where you are standing, and then there are visibility points around. So if we are in, I don't know of the visibility points in Kumasi, for instance, but let me just use anything. Let's say we are measuring visibility from KNUST, and we can see from the physics department if we see, let's say, which building. Okay, I've forgotten all the buildings in KNUST. Okay, well, so if you can see the Great Hall, you can measure, you can use any of these GIS tools to measure the distance from physics department to the Great Hall, telling you the distance in meters. So it means if you are standing at physics department and you can see Great Hall, that means you can see up to that um, distance. So if it is 500 meters to or 2,000 meters to Great Hall, it means that the visibility is 2,000 meters. You can see up to that point. But if you can see beyond Great Hall, maybe there's another electrical pole, telephone mast, or something there, which can also be seen maybe at 5,000 feet. The distance from KNU physics department to that point to say 5,000 meters. Then if you can see that one clearly, it means your visibility is 5,000 meters. So what we do is we have visibility points around all our stations, and they are usually very tall objects, which can easily be located anywhere you stand. So we also have the distance from that particular area to those areas. So if you can easily locate any of them, then that is your visibility. So the highest you can see is used to determine your visibility. So during the early hours of the day, maybe when there's misty and foggy conditions, you'd want to rely on the very near objects because you cannot see so far ahead. So if you look just closer to you and you can see some few meters, use that one to determine your visibility for that area. So it's just how far you can see in meters. Yes, it is. Actually, that's one of the problems we have with manual observations. You would tend to get some of these errors because of the person who is going to take those measurements. But over time, we've realized that it's even better using that kind of estimation with its errors than relying on instruments for measuring visibility. They most of the time will mess you up. Okay, we can do that if it's okay. Okay.
Yes, sir. Vi- Vision.
Yeah, please.
Please, about the visibility.
Yeah.
So when you go to Kumasi Airport, the metro office is in the same tower as the ATC. So checking visibility, are you supposed to be at the tower level, or you can just stand at the terminal or the aerodrome to measure the visibility?
Okay. There's any other question?
I learned it. She said it was a mistake. So
Okay. Okay. So let me start with the visibility. So like I was explaining, there's a reference point at every station. So the Kumasi Airport, for instance, the reference point will be at I think they stand at the top there where the Met office is within the tower building. That is where they do the observation from. Every airport station will have its own reference point. The reference point is actually selected in a way to be able to see everywhere in the airport. So you don't stand on the ground floor to try and estimate visibility because you can have some tall buildings around blocking your sight or allowing you to see some stuff around. So it's always good. That's why the Met office is always below the tower building. That's the second highest office you can see at every airport, so that you can be able to look around well and locate every object that is at the airport to properly estimate your visibility. So it's at the where the office is, but not inside, just around, so that you can see um, all the all the products there. Yeah. And I think the next one was GFS and then JDAS. Okay, that's the difference. Let me try and go there. This one. Okay. So was it this or the or you were talking about the site itself? Okay. Okay. Well, the GFS I know are just global forecast models, and so I think the difference will just be maybe the resolution of the models. I'm not too sure about them, but I know the GFS is somewhere around 20 something kilometers or so. Yeah, I think so. But I'm not too sure. I'm not too sure about the difference. Let's do that because I personally hardly use this one because of the higher resolution. So I would want to use ECMWF, which is a bit has a higher resolution than the GFS model. So prefer that one to these ones. But I know GFS are just global forecasting models. Their resolutions are usually between 11 and 30 something kilometers.
Yeah, exactly. Thank you. All right. I think there's another hand raised. So, Daniel, you can ask your question again.
Yes, sir. About the measuring the height of a cloud to be able to
Right.
estimate whether it's a low cloud or medium cloud or high cloud. Are
Yeah.
there any sensors at the airport that they use to measure the cloud height from the ground, or because when we went to the airport, we didn't see any kind of instruments that they were using to estimate the cloud height.
Okay. So again, so Kotoka International Airport is actually the standard for all the airports because it's an international airport. Most of the things that we do there are automated. So there's a ceilometer at the Kotoka International Airport measuring the cloud base. So when we are talking of the height of the cloud, we are not talking of how high the cloud has built, but we just measure it from the base of the cloud. So if there's a CU cloud, we're just telling where the cloud is starting to build from, not where it is going to. So the ceilometer is just telling us the base of that cloud, the height where the cloud is built. Yeah, so that's what we do. We use to estimate the cloud base. But for all the other stations, both airports and then synoptic stations across the country, the estimation is done by the observer. They are actually trained to be able to estimate height of clouds, and they also know the type of clouds and then the range within which they fall form all the time. And so you just estimate using your knowledge in cloud height identification. So it is that manual or using the ceilometer, but it's an instrument for measuring it. Just as it's currently only being used at the airport, Kotoka Airport.
Thank you, Josh. I think so. There's a request. I mean, Josh, if the I mean participants, if the slides can be made available to.
Sure, sure. I will do that. I will share it with you soon.
All right. I think Daniel still has the hand up. So, Daniel.
Okay.
Yes, please. About the channels that you were explaining.
Okay.
So all the channels that you were using in your slides, are they available to the agency alone or is available to the general public?
No, I gave a link to the UMET site. So this one, the second one, view.umetsat.int. You get all the channels there. That's free. It's free access. Anybody at all can get them. But they are web based, and so you need internet to get them. But here at the Met Office, because the satellite receiver is here, you don't need internet to get them. You just get them directly from the satellite.
Oh, thank you.
All right. Thank you very much. I don't know. We've already taken much of your time, Joshua, and so I'm sure if there are other questions, we'll compile them together and then later be sent to you, and then maybe we can have some documented responses of you. And then I'd like to say a big thank you to you. And I mean, it's been an eye opener, I believe. Probably if we sample the reviews of our people, whether online, in person, I'm sure we would have some positive feedback. And that's definitely going to feature into what we do, our forecast. even on the local end. Yeah, so yeah, that'll be very good. In fact, I'm sure it would bring a lot more enhancements into our work. And yeah, we'd like to say a big thank you to you, and we hope to have you again with us, hopefully sometime soon.
I hope that time will be more like in person than online. Would have made proper use of the charts, maybe analyze them together and then do some exercises together. But online limits us in a way.
Sure, exactly. We would have loved you to be here so we take an in-person photo with you. But since you're online, I'm sure we can still do it online. And so, let me just stop the streaming first, and
Okay.
then